Find the area of each circle and find the area of each circle with the given radius. Leave answer in terms of pi. Guys, quiet down. All right. Area of a circle is what? Pi r squared. Good. Okay, again, leave terms leave it in terms of pi because we want exact numbers. Okay, the radius is 3 centimeters. So the area is going to equal 3 squared pi, which equals 9 pi. Wow, is that hard? We should actually do the units, centimeters squared. Number 2, area equals 7 squared pi. It is south, which equals 40. Yes, it is. It's south. It's 9 pi centimeters squared. 3 squared is 9. No, that's an approximation. We want exact numbers. You can't because it's irrational. So I get 49 pi inches squared. And the last one. Area equals square root of 5 squared pi. Square root of 5 squared is 5 pi and feet squared. Questions, comments, concerns? Yes, it was wrong. Well, I wouldn't say it was wrong, Riso. It's not wrong. It was an approximation. Okay? It's just like taking the square root of 5. When you put that in a calculator and get a decimal, that's an approximation. Square root of 5 is the exact number. Okay? What? It doesn't matter to me. Hey, actually, this should be some review too. Concepts. An angle with the vertex at the center of a circle. You guys remember from geometry? What is it? That's right. It's the central angle. All right. The portion of the circle with the end point on the sides of the central angle. Right. Right. Exactly. It's the intercepted arc. Intercepted arc. And this one will probably be new to you. The measure of the central angle that intercepts an arc with a length equal to the radius of the circle. 1 radian. Good. Huh? Okay, a radian is the measure of the central angle that intercepts an arc with a length equal to the radius of the circle. Okay, you guys got that? All right, so I don't know if you can read this too much. So they give you a little diagram here. They give you a central angle. This is the actual angle, right? That's our actual central angle. This part is our intercepted arc. So this central angle measurement is 1 radian. And then this would be the radius, the arc. Make sense? Okay, now, you guys have been working with degrees, right? Now we're in math. So we're going to use radian measure from now on. Those of you who are going on in mathematics, this is extremely important for you, especially the unit circle. Yes, sir. Sure. All right. So if we want to switch from radian to degrees, if we're in radian measure and we want to switch to degree measure, all you have to do is multiply. Writing this out because it's kind of hard to read that. Multiply by 180 degrees over pi. No, you cannot use just 3.14 anymore. You guys are in big people math. That's little people math. Using 3.14 for pi. Okay? That's an approximation. It goes on forever. Okay? So you have to use pi if you're talking about measurements. All right, if you're going from degree, no. If you're going from degree to radians, you're going to multiply by, it is, no, well, it's an irrational number. Pi divided by 180 degrees. Okay, so we're going to do some conversions. No. You can leave it in degree because we are not going to approximate, so we're going to actually use the pi symbol instead of. Okay. All right, so we're going to convert from radian measure from degree to radian. So we're going from degree to radians. We're going to multiply by pi over 180. So 60 degrees times pi over 180. Okay, what is, how many 60s go into 180? 3. So I have 1 pi over 3. If you're in radian measure, you're going to have pi in your answer. Yes. Yeah, you know you're in radian measure because there's pi in the answer. Okay, so if you want, you're going the other way. Okay, negative 135 degrees. We're going to put it in radian measure. So negative 135 degrees over 1 times pi over 180. Okay, now 180 degrees does not, 135 does not divide into 180 evenly. So what we have to do, we're going to end up with negative 130. We're going to end up with negative 135 pi over 180, right? We do have to simplify here. Yes. And we're not going to trust ourselves because my brain hurts too. Let's do math enter. 135 divided by 180. Math enter. I get 3/4. So I have 3 pi over 4. Oh, yeah, we still have a negative. My fault. Because I skipped that section. If I'm on a graph, and I want this angle measurement, I could go this way, but if I look at it this way, this is going to be a negative. Okay, say that's 180 plus 30, so maybe that's 210 degrees. But here it's going to be 360 minus 50, so it could be negative quadrant, yes. Okay, C. What class left? All right, C. Guess got to wait till for him to come back. I have 155 degrees over 1 times pi over 180. I know I'm going to have pi in the top. Let's see, 155 divided by 180. Enter, math, enter, enter. I get 31, 36. Yeah. Okay, you ready? Now we're going to go from degree, radian to degree. Okay, so I'm going to multiply this. We're going from radian to degrees, so 180 degrees over pi. This time what cancels out? Our pi's. So I get 180 divided by 6, which is 30. No, no, it's not an equal sign. Okay, going to multiply by 180 degrees over pi. Pi's cancel here. 3 goes into 180 how many times? 60. So I have all ones in the denominator. 4 times 60 degrees? 240. And C, I'm going to multiply it by 180 over pi. Pi's cancel. 3 goes in 180, 60. So 2 times 60 degrees is 120 degrees. There's what? Yeah, I'm multiplying straight across. Oh yeah, yeah, that's how you do that. Okay. Any questions thus far? No. This was the easy part. No. Well, you can, but I can probably give you a smarter. We are all asking that question. Okay. This is what we call the unit circle. This will be embedded in your brains if you go on in mathematics. So, this is radius 1. Okay. We're starting at 0 here. This is radian measure, right? Okay. So this is 30 degrees. This is 45 degrees. This is 60 degrees, so on and so forth. And our radian measures are here. Pi over 6, pi over 4, pi over 3, pi over 2 is 45. Don't worry about that right now. What you have to know is that these points in the circle, okay, where it says like for 30 pi over 6 here, that is radical 3 over 2 comma 1/2. That's the point. That's the ordered pair for that. And instead of x and y in radian measure, it is cosine comma sine. So this is what you have to remember about these coordinates. This one's cosine, that one's sine. Yes. It takes a weak explanation of it. So I'm just I'm trying to do this without having to explain the unit circle. Okay? We're just looking at, we're trying to look at just radian measure here. Now, we're going to evaluate 3 pi over 4. Okay? And Derek, we want the sine of 3 pi over 4. So what we're going to do is we're going to look up the angle 3 pi over 4. So we go here, we look it up. Hey, here's 3 pi over 4. Now, we want the sine of 3 pi over 4. So which one of these coordinates do we want? Radical 2 over 2. Okay? Now, the cosine of pi over 6, which is 30 degrees. So we're going to start at 0, go to pi over 6. We want the cosine, which is the first coordinate, radical 3 over 2. Okay? That's all we're doing. We're not, well, yeah, that's all we're doing in algebra 2. Okay? Here we have the sine of 11 pi over 6. So we're going to go 11 pi over 6, which is here. We want the sine, which is negative 1/2. Okay? You can just look at all of them. Huh? I will give you the term. Okay? All right. Last thing we're going to do here. This should be review, hopefully. We're going to find the length of the intercepted arc. You guys remember this? The length of the intercepted arc is represented by S. It's going to be the radius times the measure of the angle. Now here's that theta thing again, okay? So the measure of the angle is theta, the central angle, and we're just going to multiply it by the radius. Okay? Find the length of the intercepted arc. So this is our S. They want us to find S with a central angle with the radian measure of 3 pi over 4. And what's our radius? 4. It says 4 here. Okay? So that's 4 over 1. What's the length of my intercepted arc? Yeah, cancel the 4. So what am I left with? 3 pi over 1 or 3 pi. See how easy that is? This is a kind of a... Oh! You know, it wasn't bad, except for those ladies over there were talking really loud. 2 3/4. Okay, 2 3/4, because I wasn't paying attention. I was talking. I was talking and don't care about math. Did I swear on this? Did I use profanity because I recorded it and I want to use this? Yeah, I forgot I was recording it. Yeah, that's a pain in the butt, though.